I'm Ron Noonan. I'm a product manager with SUSE. I work with Cloud Foundry and platform as a service in general. I'm going to talk about, in this slide deck, well, first of all, I'm going to tell you why I'm not going to follow the slide deck entirely and leave it up to you to ask questions and help drive it to a different direction. I have slides in here that cover some basic things that SUSE is doing with Cloud Foundry. And I'm going to cover those things and we can talk about them. But then this morning in the keynote, Nils and Michael Miller talked about some other things that we were looking at and talking about with Cloud Foundry. And I'm very willing to talk about that, but they're not in the slides. They were brought up today, and to the extent they brought it up, I can bring that up and talk about it and maybe talk about what that vision is that's behind that. And I think that's useful. Actually, to me, that's more interesting than what's in the slides. But we'll start here. So really, the slides, what we're going to cover today and what we have here, I can't really see this, is we're going to be producing a SUSE stem cell and building a SUSE-based implementation of Cloud Foundry. And we're going to do an upstream installer that allows you to take Cloud Foundry off GitHub and install it. You can do that today. It's just extremely complex. We're going to make a simple little wizard that allows you to take it and pull it. And it will validate OpenStack and do a bunch of things that you can't get on the market today that's kind of hard to do. But really, you know, what does that mean? What do you care? What is it all about? What we'll do is we'll go through this. We'll talk about platform as a service. Just take a step back. What does it do? What problem does it solve? What Cloud Foundry is, what problem it solves, and what its architecture is, and then what SUSE is doing within that architecture to build a SUSE-based Cloud Foundry. And I can go through those slides, and then we can talk about what is it that SUSE's vision is based on some of the things that were talked about this morning in the keynote, and what that means when we start thinking about taking a SUSE implementation to market with Cloud Foundry, because we have a vision that's a little different than the standard Cloud Foundry. And I would like to cover that, not in the slides, but I can tell it to you. And it's really related to the last session that was Kubernetes based. First of all, I just to help me when and how much time to spend on some of these topics, how many people in here already know everything about what a platform as a service is? Some, it's kind of new to some. And how about Cloud Foundry? Understand Cloud Foundry today. And so there are two of you, maybe three. Of the Cloud Foundry implementers or understanding, do you understand how the architecture works? A little bit. Okay.
More or less.
That's perfect. That meets my ability to explain things.
I'm still learning about the new garden.
Okay, so I'm gonna touch on that a little bit in this. So platform as a service, there's a nice statement. This is what it says it is. Really, it's a platform to build applications that, instead of writing to an operating system and a server, you're writing to a platform that doesn't know anything about where it's running or what it's running on. It's designed to provide you all the services and everything you need so that you can build basically web-native applications. It's like the operating system for a web application or a microservice-based application. And it provides everything you need. And I often hear people pitch Cloud Foundry like this. These are not my words, but I've heard this used. And really what is interesting is if you just distill it down to these pieces, every business today has to worry about being a software company. And what platform as a service does is it helps you become a software company regardless of what kind of industry you're in. You need to get better, and this is the pitch, you as a business need to get better at building applications and deploying them more quickly. So your people building your line of business applications can spend more time on the line of business application and less time worrying about how to get it running and how to keep it running and how it operates. That's the pitch for platform as a service. And this is really it. This is the bottom line. You're a software company, you've got to do it. And the fortunate thing is there's a whole industry now that's built to do this. My favorite slide, it's just one line. You know, if I take this into a stack model, I've seen this a dozen times. I recreated the same box model that I see on the internet in lots and lots of places. Yeah, I got to carry this. You know, on the left, it's like you do everything. You know, if you do infrastructure as a service, then you have a lot handled for you. If you run a platform as a service, you're responsible for building the application, you're responsible for the data stores, and everything else is taken care of by the platform. You just write those things and you push it out, and that's all you have to do. Make sense? Does it sound credible? Or sound like pie in the sky? Because this stuff really works. It's not brand new. This is kind of a, I found a picture like this on the internet and I recreated it and put it up here. I liked it because really, that's the idea of a platform as a service, and it's the idea of Cloud Foundry. Is you sit there, you write your code, you do a push, and everything that happened here happens for you. You can really just do it's not just continuous integration or continuous development. It's continuous deployment all the way out. If you wanted to have it automatically pushed to production, it would. Not that most people would do that, but you can. It doesn't care. If you tell it to automatically push to staging, it'll push to staging. The things it's going to provide to you, it's going to provide, when you get into Cloud Foundry, let's take a step back. I just went through the platform as a service. I'm going to jump into Cloud Foundry. There's really only a few realistic implementations for platform as a service that you can find on the market. One of them, which is the leading one on the market that has the most participation in the open source project, it has the largest revenue pile associated with the implementations on it and the largest number of implementations, and it has over 63 companies participating in its development, is Cloud Foundry. And that's the one that SUSE also participates in. We're a member of that foundation, and that's what we're going to talk about. Cloud Foundry is a really interesting platform as a service because it provides you, and I'll just kind of jump through this. Well, so this is a quote from one of the Cloud Foundry vendor CTOs, and talks about why and what it really does. And it's there to solve a problem. It's there to let ordinary folk concentrate on what they need to do to build applications and not worry about the rest of the stuff. But if I go into Cloud Foundry itself, you can basically write in any language you want in the platform, build an application using any number of services that are provided to you inside the platform. So you have numbers of services provided by the platform. You use those services inside or in the code you're building. And then you decide that you want to publish it and push it out. So you write your application, you use the embedded services that's very high level. And then you tell it, that's what I want to do. And then the platform compiles, stages, starts, scales, and monitors the applications. It does a complete lifecycle management of those applications. What you do is you write in the language you want, using the services that you care about, inside that platform, and then push it out. So what is Cloud Foundry with SUSE? This is you mentioned Garden. So this is just kind of a really simple what I call architecture slide for the architecture for Cloud Foundry. It's got a lot of pieces in it that handle all of these things. But right up there on the top, I've abstracted out, there's this process that you go through when you build your application. It will then take something called a stem cell, something called a stack cell, which up there is called the root file system, and build pack instructions. And it will use that with the code that you provided and compile it into what ultimately gets deployed into the application as sets of containers and run. So in Cloud Foundry, the native container that's inside of Cloud Foundry is called Garden. It's a Garden container environment. It's not the same as what you heard from Docker earlier today, or probably everyone in the market. You hear Docker a lot. Docker's a different container format and image format. Cloud Foundry uses Garden containers. So just to touch on your point, and I'm sorry, could you remind me of your name?
Dennis.
Dennis? So we talked last night, but I was, this is being recorded too, that's great. The Garden aspect of your question earlier, They just announced some new stuff with Run C and new Garden formats. Really what they were pointing out is the new Garden will be able to run Docker images natively. So if you've got Docker implementations and you want to roll out a Docker container into this environment will be able to handle it. And it isn't Docker per se, but since they both use the same image engine or the same format there, you'll be able to transparently just use Docker images and deploy them in the environment.
Yeah, my understanding is that it can build packs with Docker. So you can use Docker for a build pack.
Yeah, maybe I need to read some of that again because I'm not quite clear that that's, yeah, that could be. I'm not sure. There's a reason I'm not going to be sure because I'm going to tell you where we're going, and it's not going to matter for us. Yeah, well, and it's the fun part. It's where really interesting things happen. So, when you're building these containers out and using build packs, the stem cell provides the kernel, the file system provides the image of the container, and then the build pack is the instructions and stuff that goes on to describe what you're going to do and build it. And by the way, I come completely clean. I made these images by recreating pictures I saw on the internet. So everything I found was pretty much up on Cloud Foundry's wikis and things like that. But really what's going on here is you've got just this environment where you've got internally blob stores, a database, and a runtime. And when it decides that you're going to push something out, you'll go through and say, well, I want to push. It's going to create the app. It'll go through it'll go to the build pack and decide based on a number of scripts inside the build packs and the scripting system that whether this is something it needs to do, if it is, it'll pull the associated blobs that are a part of that. It will pull the package, it'll pull the stem cell, it'll pull the root file system, the stack cell, and it'll pull your code, and it'll compile it into ultimately what they call a droplet. And then that droplet is what is then deployed. So, you go through this system, it does all of these things, and then this becomes what runs in here. And that's how it's kind of like, well, it already exists. Build packs are not new. Cloud Foundry did not invent them. You see that same build pack system on other systems, which is fundamentally different than the way a lot of Docker things run. You're okay with that?
It's much better. I'm not a big fan of Docker, by the way, because it complicates things.
Okay.
Cloud Foundry is good at it, just simplifying it.
And I really like that. Cloud Foundry, because you don't have to do much up front. You do everything inside it, and you don't have to worry about this stuff. Everything I'm describing here, I'm describing because of what SUSE is going to do to build a SUSE implemented Cloud Foundry. But as an operator and or a developer, you don't see any of this. This is just what actually happens. What you see is this. Developer, step 1, CF push. 2 through 9 or 12, you don't do. The platform does. And this is what's going on. It's just creates the app, it stages it, and you can start the app. Stop the app, you can update the app, and you use the same process.
So is the idea that you would do that for any Cloud Foundry implementation, exactly the same? Assuming...
If you were living within it's a nice way to say this, or not even a nice way to say this. If you live within the opinionated rules of the platform as a service, which Cloud Foundry is, and you follow it and you build nice microservices and you don't have local store kind of persistence, and you write your code and you publish it out that way, all that happens and you don't do anything. Right? You live that way and it works. If you try to do things that are different than the standards, there are things you can do to control that, and then at some point you're taking controls. I'm not sure I answered your question.
I think so. I guess I was thinking like, okay, say you have a Python app, just to pick some language,
Yeah.
right? You push it,
Mm-hmm.
and it goes off, and then you have an app running on your platform.
Yes.
Right. Could you do that? Say you have a SUSE Cloud Foundry implementation, you have a...
If I do this.
same code, as long as it supports the same languages,
Mhm.
platform, it will just work the same way.
Yes. And so what we will do is SUSE, and what we've already done is build a SUSE stem cell, which is what the kernel comes from. So we're going to use SUSE hardened stem cell based on SLES and Leap if people want to use that, which is also now based on SLES. And build a stem cell, and we will build a stack cell so that when you pull that and install it with the installer we're going to build, it will put this stuff in place of what's there today. And then when you build and go through your build packs, what it ends up putting out there will be SUSE-based containers with your application code in them, built and compiled by the same system that runs today. So essentially, this is what's going to happen. You're going to have a SUSE stem cell that you're going to get. You pull Cloud Foundry. The installer will pull Cloud Foundry from GitHub. It'll pull a SUSE stem cell and those components. You will do exactly what you did before at that point. You will install Cloud Foundry, and then when you run a CF push, all of this stuff happens and it builds that droplet. That droplet becomes a SUSE-based implementation using hardened SUSE SLES-based componentry. It's a lot of fancy pictures, but that's what we're doing. I just said my pictures are fancy. That's great.
I've got to ask a really simple question.
Yes.
So fear of exposing myself as someone who's not educated around this at all. But to be able to run that droplet in your infrastructure, you need Cloud Foundry wherever you want to run that droplet.
Yes, Cloud Foundry.
Right.
This Elastic runtime, the whole thing, these droplets run inside of the Cloud Foundry Elastic runtime.
You couldn't effectively compile it and then deliver it in other platforms?
No, it would only, and it is specifically, well, actually, people familiar with Heroku? I think you can take these build packs and run them in Heroku. They're the same.
Right.
So I don't know that you would do that, but
They might need to. But
yeah.
you need an environment
Yes.
constructed in this way for them to exist.
This is not a self-standing component. It's a droplet that runs inside the Elastic runtime that the Elastic runtime knows how to manage.
Yeah.
It does. So there's all kinds of stuff that differentiate this kind of architecture then from like a container as a service kind of model. Whereas, container as a service, I might use Kubernetes, I might orchestrate it, I might have labels and pods and really metadata then to describe how to deploy it and how it scales up and scales down. But what it doesn't provide me that I would have to code myself is, well, how do I do log management? What is it that I do to do lifecycle management of the image applications and the overall application that's deployed? And that's up for the developer in that model to build and run. In this model, when you use this kind of format and it runs within the infrastructure handles all of those activities for you.
So those decisions have already been preordained.
They're built into the system. Yeah. And so that's kind of one of the nice things that happen. Yes, Dennis.
If I may comment on this. So the Cloud Foundry, people call it operating system for the cloud.
Yes, they do.
Technically, this droplet is just the application for this operating system.
It's a workload.
This operating system
Yep.
can run on multiple pieces of hardware, but it is your operating environment, so you have to deploy Cloud Foundry this droplet.
Yeah, and they only know how to run there.
Yeah.
Yeah, absolutely.
That's kind of where I was going.
Yeah.
Just wanted to
Okay.
tell it.
And that's correct. And if I take it a step farther, I mean, it's really just simplified it. It's going to run inside of Diego, a Diego cell. What our installer is going to do is it's going to be an intuitive installer. It's a graphical user interface that's basically going to just step you through like a wizard, pull it down from GitHub. It'll validate your OpenStack implementation, which actually is extremely popular. In the last Cloud Foundry Summit I went to in Berlin just a few months ago, this OpenStack validator that we're putting in here was talked about by several different vendors, IBM and others, to talk about how useful it is. And it's something that really just got written a year ago. When we started working with OpenStack and Cloud Foundry, we realized how hard it was to install everything. And so we wrote a validator because we realized that Cloud Foundry people don't know that much about OpenStack. And so they don't know how to do anything. And so if you give them a validator and it tells you what it's missing, then it's easy to figure out what to do, or a lot easier. So it'll do that. It simplifies the documentation process because it'll be a documented install with this set of components for the install, which is different than the way it's laid out in GitHub. And it will install the SUSE stem cells and the SUSE stack cells as part of the process. And it will be obtainable through SUSE, and you'll be able to get it and then use it with the Upstream components, and it will work. You, in this model, and what I just told you then is, you don't have to buy this. It'll be something we provide as a project, as a component that you'll be able to get and add to the environment in the world of Cloud Foundry. A lot of customers of Cloud Foundry, customers being customers, don't buy a distribution. They just use the open source implementation, somewhat like OpenStack. Other people like to buy a distribution. It depends what you're using Cloud Foundry for. And it's the same stuff by and large, but when you buy a distribution, there's a lot of added capability of UIs, management consoles, installers, things like that, and the open source version didn't have that. We want to help, and we have some very good partners that use the open source version. We are working with some of those partners to make this use easier and to be able to use not a community-driven stem cell, but a enterprise-based stem cell, so that when you deploy this, that's what you get. And so this is what I wanted to talk about. But in the slides, what I want to talk about beyond that now, and what is going on in from the how do I say this? From what Nils and Michael Miller said this morning. They mentioned that we have a vision and Cloud Foundry is part of it, and that we've got some ideas about some stuff that we would like to do. Essentially, what our vision is we're going to release a cloud, or I shouldn't say we're going to release. We're going to work with and/or have and/or partner with a Cloud Foundry implementation. I say that because that's what I have to say. That is based on Kubernetes. So today, Cloud Foundry uses Bosch inside to do all of the deployments and arrange everything. We do feel that Kubernetes is a pervasive orchestration environment, that it will be used at the operating system level to help distribute operating systems. We believe it will be used to manage containers and be a very prolific environment for managing containers. And what we don't think should happen is that when you decide you want to add this level of control to your environment for an application, that you have to have a completely different architecture than the one that's handling containers, that you can have lifecycle management and all of the components and a CF push that handles all of those things just the way it does today, but built on the same infrastructure that's doing the container management. So that you can have one infrastructure that manages the platform as a service applications and your container service applications. And that you will have all the same richness and capabilities here, but you will be able to deploy Docker images as part of this. And it will use Kubernetes to do the heavy lifting, and it will use Kubernetes to deploy the services, and it will use Kubernetes to deploy Cloud Foundry itself as a set of containers. That everything will be based on that common infrastructure. But this is what we're going to build it out of. So it's a little bit of our vision's a little different than what's the standard Cloud Foundry, because today Cloud Foundry predates Kubernetes and it doesn't include it. But we do think that this is the valid direction for Cloud Foundry. And that's not in my slides. Unfortunately, I'm being recorded, so there is an audit trail. But I wanted to put that out there and just say, well, what is it that you think is important about Cloud Foundry? What questions do you have? I mean, SUSE is very dedicated to building an enterprise-hardened implementation of Cloud Foundry, providing that stem cell infrastructure to other distributions and to the upstream market for those that want to use Upstream. But then we also want to build and build on this vision that we do think that a Kubernetes-based Cloud Foundry will be valuable in the market. Dennis?
So you're not using Bosch at all? You're just replacing Bosch with Kubernetes altogether, everything?
Mostly, yeah. Yeah, and it's a little bit, what would you say? It's a little bit edgy to do.
Well, I just never thought about it.
They do the same thing, more or less. You know, I'm sure if there's a developer in the room, they're going to go, no, they don't. But they do the same thing as far as what people care about. And yeah, I just said developers weren't people. Didn't mean that. What I meant is they do the same thing at a functional level, but they do it slightly differently. But in the end, you won't see the difference. It'll still be the same thing.
Bosch is down there, and I'm not a Bosch expert, but I know the learning curve for Bosch is really steep.
Yes.
You have to invest a lot of time just to understand Bosch. Why? Because
That is exactly right. And Bosch doesn't have the level of abstraction that Kubernetes has. It does a lot of stuff, and Cloud Foundry really only uses part of it. I mean, Bosch is a big beast, and I don't want to bash Bosch per se. It does things really, really well. But you get better abstraction from Kubernetes, and I think we can adjust and make advancements faster with something that has less attached code and better abstraction. And because of that market synergy, you know, Google's behind Kubernetes. Google and a lot of other people are you know, the market cache for Kubernetes. It's moving fast. Just really, I'm a firm believer right now that when we go this direction, this will enable this to move faster.
I mean, I think besides that, there's not a lot of difference. When you look at it, one is application, the other one is container.
That's correct.
Foundry kind of, you know, focuses on the application, but still uses Docker clusters.
Yeah.
So obviously, just to manage the cluster, you could just use any cluster manager.
You could use this if you wanted, or so. But you bring up a really, I think, an interesting point that I hear this a lot. Like, well, having a single architecture for containers as a service and a platform as a service is great because then I can like evolve things. Like, well, you can't really. I mean, you can use the same infrastructure to manage different kinds of applications. But if you spend your time writing an application that's a container application that does not live within the rules that you would need to live with to get all of these things, you can't just move it without going in and, you know, butchering your application and reshaping it into this. Whereas if you wrote it as a set of microservices with no local store and the like, and it worked here, then it's here. I mean, so you have choices when you write your application. But the point is, if you have a single infrastructure, you have one infrastructure where you can make those choices and decide which applications I want to build one way and which applications I want to build a different way. And that, I think, because it's folly to think that every IT shop has one plan for every application across IT. I mean, every application has a different level of importance and a different amount of investment to it. So that's what, you know, I'm probably way ahead. I am.
Do you go into how you're delivering each bit? As a SUSE guy, I'm quite interested in the installer, how you're going to actually, have you made decisions about how that installer will deliver?
You mean where you get it?
I'm thinking more whether or not you're going to use some of the other installation techniques we've got with
yeah.
business.
So we have talked about that, yeah. And for the upstream part, it's still under discussion. But this is, I can say one of the requirements that we have when we want to make sure we accommodate is that you don't need anything else that's large or complex to use this.
Right.
And so that's really, that what we don't want to do is have this become something that you have to then go learn how to do. So to Dennis's point, you know, Bosch it's complicated. It's got a high learning curve. Well, Kubernetes is complicated too, right? It's got a relatively high learning curve. The point, I think, is do you have to learn both, or can you just only learn one and then be able to do all of this stuff?
But the intention is the installation process will be self-contained, so we're going to productize that installation in effect.
Productize it to the extent where it's an open source project,
yeah.
and it
Similar
runs
to
like
mobile technique in OpenStack or whatever.
Yeah, it'd be something very simple, but it wouldn't require an overarching set of requirements to have in place first. So it could, you know, literally just be a wizard, you know, a web set of, and walk you through it. And by the way, I've seen some Cloud Foundry installers that really are just that, and they work fine.
Is the installer going to target the Kubernetes version of Cloud Foundry, or is it?
No, this installer is to install the Upstream version.
Okay.
And the Upstream version is still Bosch based. When we do a Kubernetes version, when we come up with a way to get that done, that will be in addition to this.
Are you going to push it to GitHub and make it open source?
Oh, everything we do is open source. SUSE doesn't do anything that's not open source and that's not available completely open. No, we won't do any component that doesn't have it. Question or just, yeah.
I just wanted to say that I'm really excited about this idea to have this Cloud Foundry based on Kubernetes, because the line between Kubernetes and Cloud Foundry is really blurry. Because
It's almost like this.
yeah, for example, not to contradict you, but things you said before, like log management and deployment, this is already taken care by Kubernetes. So there's really no purpose in reinventing the wheel with Kubernetes as PAM. So you can really reuse what Kubernetes offers you and just focus on the last bits, which is I do the push and I get my application packed somehow running, which is the real advantage of PaaS.
Yeah.
So it's really brilliant idea.
And when I say things like that are wrong, things are moving fast. Everything I said today will be wrong at some point anyhow.
Exactly.
So that's my excuse.
The deployment has been released some months ago. So.
Yeah. No. I think that's a great point though, because Kubernetes is really going to keep adding that kind of stuff, and it's just going to become redundant if you don't have it as a single offering.
Yeah, but it's all layers, so every layer is responsible for something, for some functionality, and at the end we're just writing containers.
Yeah.
If it's Garden container, Docker, whatever, the question is how do we build those containers, the images? My problem with Docker is it gives you too much freedom.
Yes. And you don't have to, in Cloud Foundry, so that's a perfect point. But that's kind of also why I tried to say not every IT application has the same requirements. Because some people don't want to spend the time to do it this way. And they want to just, I just want to blow out a simple monolithic container and I'm fine with that. Or other people go, no, this is a really strategic application that needs to scale. And I need to be able to scale up and scale out. And I'm going to follow all these well set out rules and I inherit all these benefits. And I can use the same system to do both.
Well, Cloud Foundry just has this thin layer of construction on top of containers, whatever containers you choose to use. It's a thin layer with this Heroku style build pack. So you just marry your application with the proper build pack and create a container automatically. Right? It doesn't matter what container engine you use to run them.
Yeah, ultimately, when this is up and running, it won't matter to the developer or more theoretically the operator what they're doing, or that this stuff is different. But if you do reach inside, or if you do have things where you're doing container services, you'll have a model you understand that you took the learning curve on one of the technologies and you know how to do it. Other thoughts, questions, ideas, comments?
I like the idea. I think that's certainly from the OpenStack side, Kubernetes.
We're going to try to have this out. Yeah, and we're going to try to have this out in the near future, not the far future, just to be clear. And yeah, a comment on OpenStack. I called out OpenStack on the installer. I called out the validator. SUSE is on the Upstream project. We are one of the contributors that maintains the CPI for OpenStack with SAP. And we do that work and we help maintain it. But that doesn't mean this doesn't run off OpenStack. It still runs on, it's still an abstracted IS. So you can still run it in different places. If you want to run it in VMware, if you want to run it in Amazon or different places, those didn't go away. It's still part of the architecture. Flavio.
I don't know if you can answer to that, but what do you think would be the take from Upstream about this proposal?
I have talked to different people, and I've got opinions on both. Like, there are some, you know, Bosch is a very capable environment, and it's got a steep learning curve, and if you know it, people like it. You know, it's like, I've got this investment, and I don't know why I would need to change. And then I've talked to other people, and they're like, Kubernetes is where things are going, and it's a great thing to do. I would say that, you know, we're being opinionated by doing this, but you know, it's where we think, in our opinion, things are going.
Would you design it in a way so that you can still use Bosch if you want? Or it's going to be full replacement?
You know, that was a discussion, but right now I think the leaning is just to be a full replacement and not, because you don't really see it. But that is something that was discussed at one point. I guess I can't definitively answer that. My guess is if doing this makes sense, then being a full replacement is what ultimately should make sense. Otherwise, probably not sure we should do it.
But the key point we're making here is that actually in the use case, you're abstracted far enough away from that decision for it to really matter.
Yeah.
So it only becomes a principal point if people have a real issue with that.
Yeah.
And I think that the main advantage of that is you don't have to have two infrastructures, one for containers as service where you need, one
exactly
for
where I'm going.
PaaS.
Yeah.
It's the same infrastructure, and you have total freedom to choose between one model or the other.
But we could do it where both are still there, and then you have that choice and you have the other.
Yeah.
At some point, that just gets big, but you could.
Oh, yeah, the problem with Bosch is that no one uses Bosch for anything other than no one is using Bosch for anything other than Cloud Foundry.
Yeah.
Because it was built for Cloud Foundry and no one knows about it. And it's really complicated.
It is, and it's also, from what I understand, from the development community on it, and I raise my hand here, I'm not one of them, but that are actually working with it. You know, it's big. It's a big environment, and it does a lot of things. It does them well. It does a lot of things, but when you touch it, you're touching everything it does when you touch it. And so just that environment is what it is. You can run Bosch Lite on a standalone implementation for demos and things like that, and I know a lot of people that think that's better because Bosch Lite is a lot easier to work with. But when you're in the real thing, you're using Bosch. So. Others? Thoughts? Well then, thank you.